Imagine the earth beneath your feet is constantly moving, so slowly you can't feel it, but with the power to build mountains, split continents, and trigger earthquakes. Sounds like science fiction, right? But it's real, and it's all thanks to the incredible force of tectonic plate movement. Tectonic plate movement is the engine behind continental drift, the process that explains how continents have shifted their positions over millions of years. It all started with a bold idea in the early 20th century, when Alfred Wegener proposed that continents weren't fixed in place. He noticed that the coastlines of South America and Africa seemed to fit together like puzzle pieces. Add in similar fossils and rock formations found on both sides of the Atlantic, and his theory of continental drift began to take shape. Of course, back then, Wegener didn't have the scientific tools to prove his idea. But decades later, with the discovery of mid-ocean ridges and seafloor spreading, scientists confirmed that Earth's outer shell is made up of massive plates that float on a molten layer below. These tectonic plates are always moving, pushed and pulled by the heat churning deep within the planet. There are several types of plate boundaries, and each one has a unique effect on the landscape. At divergent boundaries, plates move apart, creating new crust as magma rises. This is how the Atlantic Ocean keeps getting wider. At convergent boundaries, plates collide, and one can be forced beneath the other in a process called subduction, which often leads to volcanic activity and mountain building. Then there are transform boundaries, where plates slide past each other, causing stress to build until it's released in the form of earthquakes. But tectonic movement isn't just about geology. It tells the story of Earth's past and shapes its future. It explains why similar species of dinosaurs were found on different continents. It shows us how the Himalayas are still rising today. And it warns us about the risks of living along fault lines like the San Andreas. So why should you care about rocks moving at the speed your fingernails grow? Because this slow dance beneath the surface has shaped everything we see: mountains, valleys, oceans, and even the climate. Understanding it not only unravels Earth's history but helps us prepare for natural disasters, find valuable resources, and appreciate the dynamic planet we call home. Next time you look at a world map, think about this: those continents didn't start where they are now, and they won't stay there forever. Can you imagine where Earth's plates will take us in another 100 million years? Let me know your wildest theory in the comments.